Hello. In this video, we're going to go over graphing a rational function. The first thing we need to do is recognize any asymptotes, poles, zeros, and then we can state its domain and graph the function. So here we go. The first thing we look for are vertical asymptotes. How we find vertical asymptotes are by finding the restrictions of our given function. And what we do know is you can't have a zero in any sort of denominator. That's not okay. So what we're going to do is take our denominator and set it equal to zero. What we're going to get is we see x equals 4 is my vertical asymptote. And I will go ahead and find 4 positive on the x-axis, and we're going to draw a dotted line. This is the value that is not allowed for the domain to exist. My x can never be equal to 4, not allowed. Next, we're going to look for our horizontal asymptotes. There are a couple rules we need to remember for our horizontal asymptotes. One, if the degree on the numerator is greater than degree on denominator, then there is no horizontal asymptote. No HA, but there is a slant. Yes to slant asymptote. So we don't have to worry about that here. 2, degree on the numerator, the highest degree on the numerator is equal to the highest degree on the denominator. And then what we say is our HA is equal to the coefficients. So for example, if I had let's do an example for this one. If I had y equals ax squared plus bx plus c all over, let's do gx squared plus L. Well, since the degrees are both 2, they're the same on the numerator and the denominator, my HA is y cannot equal, or y equal to, a over g, just a coefficient. And then lastly, we have that third one we have to go over, where the degree on the numerator is less than the degree on the denominator, right? In that case, my HA will always be y equals 0. So here we're going to take out our degrees. The degree on the numerator, degree of the numerator, is equal to 1. The degree of the denominator is also equal to 1. So what we're going to do is take the coefficients of what we have in front of the x. Now, good for us, we just have a 1 in front of both x's. So r is going to be y equals 1 over 1, or just y equals 1. Now, for an example, just so you know, if this said 2x minus 4 instead, right, then the HA would be 1 over 2, the coefficient. So I just want to point that out just so it's not confusing. Okay, so we have our HA, and we'll go ahead and draw a dotted line where y equals 1, because y cannot equal that value. All right, next we need to find the zeros. Zeros are pretty straightforward. We're going to set the numerator equal to 0 and solve. X is equal to -7. So when x is -7, y is 0. We have our value here. Next, we can find our y-intercept just to help us graph these guys, because zeros are another name for x-intercept. My y-intercept, we're just going to plug 0 in for x. 0 plus 7, 0 minus 4, 7 over -4. So that's what that is. And if you want to get the decimal version of that, it's -1.75. So we are around here. Here we can begin to create our graph on this side. And next, we're going to want to test a point on the right side of our our VA. So we've tested 2 points on the left side of VA. We're going to test a point on the right side of VA. I'm going to test 5, plug 5 plus 7 all over 5 minus 4. We get 12 over 1. going to be a really high value up here. So it's 11, 12. And then let's plug in another one. We get 6 plus 7 over 6 minus 4, 13 over 2, right? Which is going to be 6.5. So at 6, we're going to go to 6.5. And we can see that this side of the graph is going to connect this way. And thus, we have our graph. We have our vertical asymptote, that denominator equal to 0. We have our horizontal asymptote, check degrees of numerator and denominator. Check degrees of numerator and denominator. Zeros, set numerator equal to 0, right? Just little hints that we can have just to remember. Y-intercept, make x equal 0 and solve for y. And then lastly, you just want to test points on both sides of the asymptotes. We have our accurate graph. Now, just to make sure we write our domain at some point of the answer, our domain, I'm going to do that in purple, our domain is everywhere but where the x value doesn't exist, which is what we found in our vertical asymptote. So since our vertical asymptote can't be 4, you see those values can't happen here. We can be everywhere else. That's okay. But not on that line. So my domain is everywhere but x equals 4, or in interval notation, negative infinity to 4, union 4 to infinity. And that will be our domain. Perfect. If you have any questions, please let me know. If there's another type of example you would like me to cover, just shoot me an email.